check. Griffin?
But like you can't get any farther than Massachusetts.
Wow, you did.
Like what was the special about it? You can't get any farther. It's literally the most upper northeastern state.
Oh my god.
You know what's amazing is like that video is from my phone and like yeah. And I remember like when I was in marching band, like you know you had to have like an awesome camera to do that, and now it's like in my pocket.
That's crazy.
Yeah.
Especially because like my phone, I have really good
Mhm.
and so it's like
I'm impressed by my phone.
I am very very helpful. Yeah, very good learning.
Thank you. Okay, so let's get started. I don't want to be here too long, hopefully. I feel like every time we do this chapter, I'm here for hours and hours with this review. So we have this integral here. You notice the x is in the denominator. It's linear in the denominator. So that's usually the sign that it's going to be a natural log. The thing I want to emphasize is that when you do these natural logs, you know, really take your time to make sure you get the constant correct, because it's really possible for you to mess that up. So let's see. We have 3x plus 1. So du is equal to 3dx. Since we don't have a 3dx, we have a 2dx. I'm just going to solve for dx. And then that'll transform this entire thing. So from here, you're going to go ahead and just make it the antiderivative. We'll get to the constants in a minute. See, that 2 is still there. This denominator 3x plus 1 is going to get turned into a u. And that dx is going to get turned into a 1/3 du. So when you take out all of those constants, you'll get a 2/3 antiderivative of 1 over u du, which of course we know is a natural log of the absolute value of u. Let's make our substitutions again. That's 2/3 natural log of the absolute value, 3x plus 1. And then at this point, I'm going to not bother with the constants because this is a definite integral. We're going from 2 to 5. Do your substitutions. You'll get 2/3 natural log of the absolute value, 3 times 5 plus 1, minus 2/3 natural log of the absolute value, 3 times 2 plus 1. Okay, both factors have a 2/3, so I'll feel pretty good about factoring that out. This is a natural log of 16. It's positive, so I don't need the absolute values anymore. Minus, this is the natural log of 7. And then to use that special rule, remember that the natural log of a minus the natural log of b is equal to the natural log of a over b. That's the companion rule to the natural log of a plus the natural log of b equals the natural log of a times b. Those two are really the same rule. So I got that. That turns into 2/3 the natural log of 16 over 7. And that's that. Now sometimes people don't like to see this improper fraction here. And if that's the case, then you'll get 2/3 natural log of 7 over 16 to the negative 1 power. That makes this a proper fraction, just with reciprocal. And then the rule here is the natural log of a to the x power is equal to x times the natural log of a. So that becomes negative 2/3 natural log of 7 over 16. He's got to kind of be prepared to simplify it if simplification is needed or necessary. So one of those two things should be the correct answer. And again, some people are offended by a negative sign in front of the natural log. But you can't win. Someone's going to get hurt. Hmm?
On the test, it's possible that they don't actually get the next one and they only use the
It's possible, yeah. It's one of those things. You have to be able to spot the correct answer, even if the correct answer doesn't look like your answer. No, that's definitely not cool. Okay, 2. You should expect something kind of similar. You have 2x over the square root of x squared plus 1 dx. Now, the ruling here is you don't want to use integral by parts unless you absolutely have to. So we're going to check to see if we absolutely have to here. Let's pretend our u was the, what do you call that, inside the square root? The radicand? So let's pretend our u is a radicand. That gives us du equals 2x dx. Oh, how fortunate. Look, we have a 2x dx right there already. So we can trade that for a u, or du. So that's equal to square root of u, 1 over square root of u, times du. See everything that got kind of done. And then this is just a regular power rule for integration. That's the integral of u to the negative 1/2 power du. Let's do this slowly. That's 1 over negative 1/2 plus 1, u to the negative 1/2 plus 1, and a constant. That simplifies into 2 u to the 1/2, which is 2 square root of x squared plus 1 plus constant. That's everything on 2. That's a pretty good solution right there. Any questions on 2? It's It's weird doing these in order. I usually do the free response questions first. Feels weird. All right, let's try this one. Integral of x cosine 2x dx. Okay, my first thought is never integral by parts. The first thought is always, can I make a U-substitution? So let's try it. If u is 2x, that makes du equal to 2 dx. Well, that's nice. I have a dx here. I got a dx there. But that doesn't get rid of this u, or this x. So this is actually the wrong way to go. X won't cancel out. Won't cancel. So that tells me that I've done the wrong thing. U-substitution won't work. So let's try ultraviolet voodoo now. Okay. Well, in ultraviolet voodoo, if you have a polynomial here and a trig here, I think I can use the tabular method, right?
Yeah.
You want to use a tabular method, or do you want to? All right. So u is x, dv is cosine 2x, derivative is 1, antiderivative is 1/2 sine 2x, derivative is 0, that's negative 1/4 cosine 2x. Okay, make sure you integrate. The number one bonehead mistake there is to take a derivative on both sides of the chart. It's a very bad idea. Okay, x times 1/2, that's equal to 1/2 x sine 2x. The second arrow is a minus. So minus negative 1/4 cosine 2x. All right, that gives me 1/2 x sine 2x plus 1/4 cosine 2x. LCD is 4. I'll factor out a 1/4. That gives me 2x sine 2x plus cosine 2x. Oops. That's good. Okay. Questions? Let's get on down to question 4. Antiderivative x squared e to the 3x. Okay, so u substitution doesn't work here. If u is 3x, I'll still have an x squared there. So u substitution won't work. This is a good place for us to integral by parts, IBP. Let's do our chart, u dv, x squared e to the 3x, 2x, make sure I integrate, 1/3 e to the 3x, 2, 1/9 e to the 3x, 0 1/27th e to the 3x. So first one, let's get that e to the 3x out of the way. We all know e to the 3x is going to be everywhere. That's 1/3 x squared minus that 2/9 times x plus 2/27 LCD is 27, so we'll make that 1/27th e to the 3x. 27 divided by 3 is 9. That's 9x squared. 27 divided by 9 is 3. 3 times 2 is 6. 27 divided by 27 is 1. 1 times 2 is 2. And that'll do it. That's 4. Okay. Questions on 4? Were these the easy ones?
Isn't that a
Yeah.
tabular method?
That is a tabular method, yeah.
How would you do ultraviolet?
Well, that's the thing, is tabular method is ultraviolet voodoo.
Oh,
It is the same thing. Tabular method is just ultraviolet voodoo, but faster, yeah. So let's write that down for you guys. Give me 1 second, Griff. So tabular method is integration by parts. It's faster, but doesn't always work. Than the traditional method. Yeah.
does it have to be an algebraic function in U just for the tabular method, or for tabular method and integration by parts?
Just for tabular method. You can integrate by parts no matter what U is. Griffin?
When would the tabular method not work, but the other method would?
I think the best example of that would be the circular variety of integral by parts, where the integral shows up again.
Oh.
Yeah, that one, no way to do a chart for that. Okay, number 5, despite what the directions say, you're just integrating. Okay. The fact that it tells you to use the general power rule, that doesn't really tell you a whole lot because you use the power rule for almost every integral. So adding that there is basically just a way for the test taker to make you second guess what you're doing. We call that evil, right? U is equal to 4 minus 9x squared. Du is equal to negative 18x dx. So if I take a look at my parts, that dx is shared here. This x is shared here. So it looks as though using a plain U-substitution is going to work. Let's see. So x dx is equal to negative 1/18 of du. So we can get rid of all of that and replace it with negative 1/18 du. So that becomes antiderivative of square root u times negative 1/18 du, which is negative 1/18 integral of u to the 1/2 power du, 18th, which is negative 1/18 times 1 over 1/2 plus 1 times u to the 1/2 plus 1 plus constant. Let's see. 1/2 plus 1 is 3/2. 1 divided by 3/2 is 2/3. This can cancel out here, right? So 2 and 9, that's 1 over 27. No, 1 over 9. 9 times 3 is 27. So negative 1 over 27 square root of 4 minus 9x squared cubed plus constant. What the heck? That's that. Just to show that that's not actually part of the main work. Okay, questions? 5? Sometimes students like these because there's a definite way of doing things. Unlike some parts of math where you have no idea if there's a way you're supposed to do it or not. Okay. So let's check. Will I be able to just use a U-substitution to solve this?
Yes.
Okay, so if u is equal to x squared plus 1, du is equal to 2x dx. I'm going to match dx, dx, x, x. Yeah, it looks pretty good. Everything is accounted for. That gives me x dx equals 1/2 of du. Let's box that up. So this is equal to antiderivative of u to the 1/2 power times 1/2 du. That's equal to 1/2 antiderivative of u to the 1/2 du. Let's try and make this quicker. 1/2 plus 1 is 3/2. This is 1/2 times 2/3 u to the 3/2 plus constant. So 1/3 of the square root of x squared plus 1 cubed. I know this is a definite integral, so I'll just replace it now. 0 to 1. Patrick? They let you out?
Huh?
They let you out?
Yeah. Tension's hardcore.
It's very nice. Detention?
Detention.
Oh,
JK, no.
I thought you were at dance.
I was. What's the difference there?
Ooh. Wow. Did you know Coven subscribes to the YouTube channel?
Huh?
Coven subscribes to my YouTube channel.
Cool.
Coven. Just kidding. Minus.
What?
You may have heard of her.
No, you caught that one too.
Okay. Yeah, it's pretty ugly, right? 1 plus 1 is 2. 2 cubed is 8. Square root of 8 is 2 root 2, is it not? So it's 1/3 of 2 root 2 minus 1/3 of 1. I don't know how they simplified this. Did they factor out a 1/3?
Yeah.
2 root 2 minus 1. This answer makes me feel like I haven't done any work. Because the answer looks like just as much work as the question.
That's so much nicer.
Okay. Another definite integral. A to B. Uh, 5x squared plus x minus 7 square root dx. And I think my strategy here is going to be to separate this into two integrals. So integral 1, a to b of 5x squared dx, plus integral 2, a to b of root x minus 7 dx. Okay, this first one I can do no problem. That's 5/3 x cubed from a to b. No problem. But the second one, well, that's going to require more work. So I'll just write it there again. All right, so I'm going to probably have to use a U-substitution. So let's say u is equal to x minus 7. Notice I didn't go right to integral by parts. Let's see, dx is there, dx is there. So it's just a one-for-one trade. Let's take this opportunity to simplify this again. That's 5/3 of b cubed minus 5/3 of a cubed plus antiderivative of u to the 1/2 power du that's 5/3 b cubed minus 5/3 a cubed plus 2/3 u to the 3/2 power 5/3 b cubed minus 5/3 a cubed plus 2/3 of the square root of x minus 7 cubed from a to b. Wow. 5/3 b cubed minus 5/3 a cubed plus 2/3 of the square root of b minus 7 cubed minus 2/3 the square root of a minus 7 cubed. Wow, that's annoying, right? And I think that's it, right? You could probably factor out here if you really wanted to go for it. Go for the gold medal. Let's say that's 5/3 b cubed minus a cubed plus 2/3 square root of b minus 7 cubed minus the square root of a minus 7 cubed. But that's not much more simplified than that. Sweet. All right. That is all sorts of not fun. Those problems I don't like as much. Okay. Hmm? You don't like that one? I would want this on a test. I mean, if I was you, I'd want that on a test. It's not bad. No? Do the A's and B's like give you worry?
Just that it's
I
so
think it's just
long.
math thing.
Just that it's so long, there's so many places.
When
you
there's
can
the
make
alphabet in
mistakes.
my math problems.
Yeah. Okay. Let's get to 9, or no, this is 8 now, right? Differential equations. Yay. E to the 4x y prime is equal to x. Well, that's not a lot of fun. Let's see. I want to separate variables. I probably won't have the opportunity to do that unless I have a dy dx. I know I want to get rid of this one, though. So dy dx is equal to x over e to the 4x, which looks intimidating to integrate. I'll admit. That looks bad. I don't know whether to U-substitute or UV-dV. But you do have the fact that you haven't really simplified this enough. E to the 4x in the denominator is just e to the negative 4x. This here doesn't look anywhere near as intimidating as this. I don't think. This one looks like I can just use an integral by parts. In fact, this looks like I can use tabular method. So if u is equal to x, that makes dv e to the negative 4x. 1, negative 1/4 e to the negative 4x. 0, positive 1/16 e to the negative 4x. Yeah, this was nice. Okay, so integral of dy equals integral of x e to the negative 4x dx. Y equals negative, no, let's make that e to the negative 4x on the outside. We know that that's going to be on the outside. So negative 1/4 x minus 1/16. Let's make sure I didn't forget anything. We got the x, we got the negative 1/4, we got the 1, we got the 1/16. Yeah, that's everything. Looks like it could factor out a 1/16. In fact, you might as well make it a negative 1/16. That's 4x minus plus 1 plus constant. Mm-hmm.
Is the answer supposed to have a plus c in it?
Yes it is. I'll fix that for next year.
Hi, Julian.
Hi, Julia. Yeah.
On multiple choice, will it be simplified all the way down?
Not necessarily.
So, like, it's possible that let's say 1/16 would be simplified.
Yeah. Or, I mean, another way to simplify this would be, what is that? Negative of 4x plus 1 over 16 e to the 4x plus constant. It's another way of doing it. That gives you a positive exponent. Don't forget that negative sign here. And 9.
On the answer sheet, doesn't say plus constant.
Yeah, I'm going to change that for next year. It should have a plus constant. Did we say 9? Yeah, we did. 9. Antiderivative of natural log of x plus 1 dx. Okay. A U-substitution doesn't work. Let me just show you why that doesn't work. If you say u equals x plus 1, du equals dx, looking pretty good. U dx. So that's equal to natural log of u du, antiderivative. That doesn't really help any, right? Not much different. Not really helpful. Of course, unless you've memorized your antiderivative of natural log of u.
Which is the tan thing.
No, not the tan thing. Okay, so this is a not a dead end, but this is a bad choice. Try UV dv. Try voodoo. Okay. So, antiderivative of the natural log of x plus 1 dx. Let's see. L, liate, yeah, there's a log function. U is equal to the natural log of x plus 1. dv would be equal to everything else, just dx. du is 1 over x plus 1. V is equal to x.
If, let's say it was natural log of 2x plus 1, it'd be 1 over 2x plus 1 times 2, correct? Since it would be like u prime.
One more time.
If it would be like natural log of 2x plus 1,
Mhm.
if we find the derivative of u, it would be 2 over
Yeah.
2x plus 1?
Yes, it would. Okay, so let's. Oh, that looks bad. Let's put u in a box. And this is now equal to uv, so x natural log of x plus 1 minus the antiderivative of vdu. Oops, I forgot the dx. So vdu is x times 1 over x plus 1 dx. Which doesn't look any easier, does it? Not particularly. Yes. Okay. Let's see. How can let's simplify that. X log x plus 1 minus antiderivative of x over x plus 1 dx. Let's see, can I use a U-Substitution? Okay. What should U be?
X plus 1.
X plus 1. That makes du dx. Okay. Put this in a box. You know, put that. No. It's going to be break time. Okay, so how does that change the problem? Now we're going to have x natural log of x plus 1 minus the antiderivative of x du over u. Wait, I can't do this. They are not the same variable. So caution. So two different variables, two variables. Okay. So actually, but in this case I can do something, because if u is equal to x plus if u is x plus 1, that means x is equal to u minus 1. My wife just bought tickets to go see Tame Impala. Huh? Tame Impala. Oh, you don't know? God. There's this band from Australia. Okay. That's exciting. x natural log of x plus 1 minus the antiderivative of 1 minus 1 over u du plus u. What a lot of work this problem is. Equals, I swear this is it. I swear. Natural log of x plus 1 minus, what's the antiderivative of 1?
X. U.
U plus the natural log of u. Plus. Which one?
The u plus natural log of u.
This one right here?
Yeah, how'd you get from the other guy?
Well, look, u over u minus 1 over u.
Oh, okay. Okay.
Tame Impala. I'm going to tell her that no one knows who Tame Impala is. She's going to be disappointed. No one knows. Does anyone know who Tame Impala is?
No.
No.
From a scale of 1 to 10, how rock and roll are
None of the kids know Tame Impala.
10 being Seabird, like 10 being Kiss,
Are they like a big band?
and 1 being like
I'll play them. All right. This equals x natural log of x plus 1 minus, what was u? X plus 1 plus a natural log of x plus 1 again plus constant. Oh my gosh.
Is this just how they consider fair?
Did it become u plus ln of u because you distributed u?
Yes, that's exactly what happened. All right, we're not quite done yet. Notice.
you probably
No, we're done with integrating.
Oh my God.
Sorry. These two terms here we can combine and factor out natural log of x plus 1. So this is equal to the natural log of x plus 1 times x plus 1 minus x plus 1 plus c.
Will it become minus x minus?
Yeah, minus 1.
I don't understand how you just got that.
I took the two yellow terms and factored out a natural log of x plus 1.
The minus 1 is
You
the
want to x plus 1 and then put negative x plus 1 so it stays there.
Okay, but did you notice that we have minus 1 constant plus a constant?
So it's just plus the constant.
So it's just plus a constant, yeah.
Would it be wrong if we left it like that?
Well, we're looking at a multiple choice part of a test. It's not wrong, but you're not going to see that answer. Okay, wow. Integral of natural log x plus 1 dx. That's where we're going to take a break.
Is that probably considered fair for our test?
This is very likely to be on your test.
What happens to the 1?
One's constant?
So eventually that's
Yeah. So constant plus constant is a constant. All right.